Okay guys, welcome back. We have a PowerPoint on index notation. Same visual, same rule reminders, nothing new. And again, we're going to have a look at our factors of 3. Counting up in threes. Again, what I'm going to ask you to do is count along with me. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33. Same with the 4s. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Great. Starting off, what we're going to do is we are going to have a look at some index laws. So last lesson, guys, we had a look at indices, index form, and what all that was about. We're moving on today to applying some of the laws and rules that apply to our index numbers. So I need you to, as we can see up here, writing down this rule in our book. The first index law: when terms with the same base are multiplied, the indices are added. Okay, we often call this law the law of addition, or the addition law, and it looks a little bit like this. So we have a to the power of m times a to the power of n. So they have the same base number of a in this rule, and what we can do is we can simplify by adding our powers together, adding our indices. So let's come down here and have a look at this example here. So we have 3 to the power of 4 times 3 to the power of 2. So the bases are the same. Good news, means that we are a tick for using our rule here. And our rule says that we can add our powers together and simplify at the end here. Now, before we get carried away, I just wanted to show you very quickly why this works. So let's write 3 to the power of 4 in our expanded notation. 3 times 3 times 3 times 3. And then we are going to multiply, so times 3 to the power of 2. 3 times 3. And what we can do is we can now rewrite it as there's 3, so our base number is 3. There's 1, 2, 3, 4, 5, 6. Okay, so if the rule looks a little bit intimidating, I know it can be a little bit intimidating, but it just makes sense. It's a shortcut for something that we would get the same answer to. Okay, so we have a redo, guys, and what I'm going to let you guys do is pause the video, okay, give you guys a chance to have a go yourself. When you're finished having a go at these 4 questions, we'll come back together, go through the answers. So if you pause now, I'll see you soon. And welcome back. So we know that we can apply the index addition law because our bases are the same. So our base is 2, and we are going to add our powers together. So I get 2, 3 plus 6 is 9, 2 to the power of 9. Bases are both 3, so we can use our rule. 4 plus 3. Good to go. Bases are both 6, so we're fine. 2 plus 3 is 6 on 5. 4, 3 plus 5. Okay, that easy. Okay, guys, so what we have here is a bunch of you-dos. So this might take you a little while. No stress, you can pause the video for as long as you need. Hopefully not too long. When you're ready, you can come back and we'll run through the answers very quickly. So you can pause the video and resume when you're ready. Okay, so if we're going through the answers, just going to zoom through them relatively quickly. They all, except for this cheeky one down the end here, have the same bases. So up until then, we're right to go. That one will take a little bit more thought, but let's get stuck in. So 3 plus 6 is 9. 4 plus 3 is 7. 4 and 5. 4 and 8. A little freebie there, double up, nice. 10 and 26. 5 and 6. 3 and 9. 5 and 7. 4 and 5. 4 and 8. Where are we? Here we go. So negatives, okay, adding positive and negative numbers. We should remember how to do this. Okay, negative 3, add 6 more. You have positive 3. Negative 4, add 3 more. Should have negative 1. And this one here, negative 2, add 3 more. We would have 1. So what we need to do is we want to simplify this, but we need the same bases. Now this problem here, okay, excuse me, a little bit tricky, so hopefully some of you might have had a crack at it, but I'll show you how I might have answered this question. I would have expanded the number 4 into a 2 times 2, okay? Now, it does require a little rule, so as I said, it's a little bit tricky, but what it ends up being something like this. Then we need to add all our powers together. So if you got it, awesome, give yourself a pat on the back. If you didn't, do not stress. We will work up to that very, very soon. Okay, so if we had a first index law, makes sense that there are a couple more kicking about, and we're going to have a look at the second one. So again, I expect you guys to be copying down these notes in your math books. And the second index law states that when terms with the same base, so we still require them to have the same base, they are divided, the indices are subtracted. And we can see our law written out here. So we had a to the power of m divided by a to the power of n. So again, the base is a and a, so they're the same. We have m take away n. So the first one, subtract the second one. That order is important. We see the example, so we have 3 to the power of 4 divided by 3 to the power of 2. So the bases are the same, they are both 3, so we can go ahead and do our subtraction. 4 subtract 2. Okay, 4 comes first, we subtract the second one, which is 2. Tidy that up to be 3 to the power of 2. Very quickly, guys, I'm going to show you again why this kind of makes sense. So if we have 3 times 3 times 3 times 3 for 3 to the power of 4, and then on the bottom we have 3 times 3 for 3 squared. If we were to simplify this, then we would cancel out some of the terms on the top and bottom in our fraction. And we end up with only 3 squared. 2 3's left, 3 times 3. So hopefully that can... What we're going to do is I'm going to give you guys a chance to practice this yourself. Another we do, if you can pause the video, try some of these problems, come back when you're finished, and we'll see how you went. Okay, welcome back. Let's have a look. So we have the same bases all the way through, so we're happy to smash these out. If I put in some working there where I'm going to do the subtraction, 6 take 3 is 3. Okay, 3 is my base, 4 take away 3, and I'm left with 1. As we said, if it's just 1, we can kind of leave it without a power. If there's a 3 there, well, it makes sense that, as I said, there is 1, 3, a 3. So they're equal to each other. 6 is our base, 5 take our other power, which is 3. So I have 2 left. 4 to the 6 take 5, which is 4 to the 1. Which, if you're happy to do it, just leave it as 4. Okay guys, and the last one here. So what we're going to do is you guys are going to have a go at all of these problems. Pause the video for as long as you need. You might need a little bit of time here. And we're just going to have a crack, apply the rule, and I'll see you guys in a few minutes to check your answers. So you pause now. And we're good to go. So I'm just going to jot down some answers here. So bases are the same, 3 to the power of 3. I'm going to subtract that power there. So 3 take 6, I get negative 3. I just get 5. I get 4 to the minus 1, 4 to the minus 2, 4 to the minus 2, 10 to the minus 20, 5 to the minus 4, 5 to the 2, 3 to the minus 3, 5 to the 1, or just 5, get 4 to the minus 1, 4 to the minus 2, so negative 3 take 6, so 3 take 6 is negative 9, negative 7, negative 5, and then that last tricky one. Bases are not the same, so I'll whack in how I like to answer this question. Very similar to the other one, dividing by 2 times 2 to the 5. So that's actually the same as saying 2 to the 5, 2 to the 5. So I'm going to have 2, take 3, take, oh, hang on, let me write that in the powers, take 5, take 5, 2 to the negative 13. Now that one again, a little bit trickier than what maybe we have learned to, but if you had a crack, that's awesome. If you got it right, even better. Okay, have a go at the worksheet, guys, and I'll see you next PowerPoint.